Hi everyone, my name is Ravi Prakash and welcome to next class of linear tracks. Okay, so again in this class we'll discuss about some very special concepts of linear tracks. Okay, so see, we'll discuss a case here, again an important concept which we can write in form of cases here. The case is, if a person travels, right, let me write here, if a person travels a particular distance at a particular distance at s meter per second, right? Speed is s meter per second in t seconds, right? So I'll derive this for concept for variables st, s1, t1, and parallelly we'll understand it for numbers as well, right? So for example here, time being, assume s to be 20 meter per second and t to be 5 seconds. So total distance is what? 20 into 5, 100 meters, right? Total distance is 100 meters, okay? Speed is 20, t is 5, so total distance is 100 meters, right? 100 meters, okay. Now, if speed is increased by s1, right? Now you'll see here, if speed is increased by s1, if speed is increased by s1, but distance is constant, right? Distance does not change. Distance is traveling the same distance here, same particular distance which we are referring here. Okay, so distance is same here, distance is 100 meter. Okay, so let's say speed is increased by s1, and if distance is constant, then time has to be decreased, right? So time is decreased by t1 seconds. Time is decreased by t1 seconds, right? Let's assume some data here. Assume s1 to be 5. s1 is 5 meter per second and time t1 is suppose 1 second, right? What will happen? The new speed is how much? It is 25 meter per second, and time taken how much now? Time taken is 4 seconds now. New time is 4 seconds. Again, distance is what? 100 meter, right? 25 into 4, so same thing. Okay, so what I'm trying here is, I'm deriving a particular concept in terms of s, s1 and t, right? But parallelly, with the help of numbers also, we're trying to understand that concept, right? So I'll derive a final formula here, which you can easily relate with terms of these numbers here. Okay, so I'm deriving a formula, this in terms of variables, and explaining that concept with numbers as well, right? With numbers, it is a bit easy to understand, right? So time is decreased by t1 second now, right? So see here, now I'll write that distance, okay, time is traveled by t1 seconds, okay, so time is decreased by t1 second, speed is increased by s1, right? But if time is decreased by t1 second, right, and if speed had not been increased, okay, let's take a case here. Time is decreased by t1 second, but speed is not increased, right? Then s into t1 should be the distance supposed to be decreased. S into t1 was a distance supposed to be decreased. Correct. Come again here. If speed is s, and time is decreased by t1 seconds, okay, so if speed is not increased and only time is decreased, so distance was supposed to be reduced by how much? Reduced by distance is speed into time, s into t1. Okay, in terms of numbers here, you can see here that this s1 is how much? So speed is 20 meter per second, okay, and t1 is how much? T1 is 1 second, okay. So what is st1? st1 is 20 into 120. So 20 into 1 was a distance that was supposed to be decreased, but distance has not decreased, right? Distance has not decreased. Why distance has not decreased? Because speed is increased. Okay, so this decrease in the distance is compensated by, okay, this decrease in the distance is compensated by increasing the speed. Increasing the speed by what? S1. Okay. And S1 for how much time? So obviously for rest of the times, that is, rest of the time is how much? Out of T, T1 second is already done, right? So for rest of the time, how much? T minus T1. T minus T1. Okay. In numbers, I can say here 20 1 is equal to, this is 20, right? What is S1? S1 is 5. What is T minus T1? That is 5 minus 1. So correct, right? That means 20 is equal to 20. So it's right. This formula is correct, right? This what I explained is correct, right? That's what I wanted to show by taking numbers. Okay. So understand this concept here. Distance supposed to be decreased, and this is distance to be increased to compensate it. Right. So again, come again here. Why I wrote this ST1? I know that time has reduced by T1 second. Okay. Time has reduced by T1 second. So if only time was reduced and speed was not reduced, right? Listen here, you'll enjoy it. Okay. If time is only reduced and speed is not increased, that means distance will reduce by how much? S into T1. Okay. What I'm telling is, if time is reduced by 1 second, okay, and distance is not reduced, so speed is not increased. If time is decreased by 1 second and speed is not increased, so distance will be decreasing by how much? 20 at the rate of 20 meter per second for 1 second. That is 20 meters. Okay, but distance has not been decreased, right? By decreasing time also, distance is same. Why distance is same? Because this decreased distance is compensated by increasing the speed. Okay, why there is a decreased distance? Because decrease in time. This decrease in time is compensated by increasing the speed for a particular time, right? So out of T seconds, if at the rate of S you'll travel for T1 second, you'll travel a distance of 20 meters. That is 20 meters less. Okay, again, how this 20 will be compensated? By the increased speed, that is S1. Okay, for the rest of the time, that is T minus T1. Okay, what is the rest of time here? 5 into T. S1 is 5. S1 is 5, and T is also 5, and T1 is 1. So 5 into 4 is again 20, right? So this is what? This is correct. 20 equal to 20. That is correct. Okay. So right now you can write here. So I can write this data here as very important point. ST1 is equal to S1T minus S1T1. Okay. So it will come here as ST1 plus S1T1 is equal to S1T. Therefore, I can write T is equal to S plus S1, and I can take T1 common from here. S plus S1 into T1 upon S1. Yes. So T is equal to S plus S1 upon S1 into T1. Very, very important point, right? If distance traveled is same, speed is increased by S1, time is decreased by T1. So relation between all this data is T is equal to S plus S1 into T1 upon S1. Correct? Okay. Now come here. See, same thing data, same I'll take. If in the second case, if speed is decreased by S2 meter per second, and time is increased by T2 seconds, then what I'll get? So you can compare with the previous formula, right? You can compare with the previous formula, right? What is the previous formula? So let me write first previous formula. Okay, if speed is increased by, let me write first previous formula, then I can compare it easily. Okay, if speed is increased by S1 meter per second and time is decreased by T1 seconds, okay, then T is equal to S plus S1 upon S1 into T. T1 into T1, right? Into T1. Correct? Okay. So what is S and T here? S and T is the original speed and original timing. Okay, so S and T are original speed and original timing. Okay, now second point here. So I can write if speed is decreased. Okay, if speed is decreased, right here. If speed is decreased by s2 meter per second, and so if speed is decreased and distance is same, so time has to be increased, right? So time is increased by t2 seconds. Then again, I don't need to derive that formula. I can directly write that. Then compared with this formula, I can write then t is equal to s plus. Okay, I can write t is equal to s. Now it was plus s1 for increased s1, plus s1 for increased s1. So minus s2 for decreased s2. Okay, upon s1 here. So here upon s2. Okay, and into t2. So again a very important point. Right, this has to be got a very important point in linear tracks. Okay, you can solve questions with great ease, right? With great ease if we know these points. Okay, bit of practice and we can know these 2-3 points. Okay, and it will be very helpful. Okay, so my third case is now if t1 is equal to t2. So if t1 is equal to t2, right, what will happen now? What is t1 here? So I can write t1 from here as t1 is equal to t into s1 upon s plus s1, and I can write t2 as from here as t2 is equal to t into s2 upon s plus s2. So if I equate this, t into s1 upon s plus s1 is equal to t into s2 upon s plus s2. What I'll get? T will get cancelled. You cross multiply, you will get s is equal to 2s1 s2 upon 2s1 s2 upon s1 minus s2. 2s1 s2 upon s1 minus s2. Right? This will get. Let's just solve it. Right? You can solve it. This you can easily solve it. Do cross multiply and solve it. You will get s is equal to s1 s2 minus s1 minus s2. Sorry, s equal to s1 s2 upon. Okay, so after solving, what you will get? You will get s equal to twice of s1 s2 upon s1 minus s2. Right? This will get these 3 cases very important. These 3 cases very important. Correct? Now we can do questions here. Okay, see the question here. If Ritika increases her speed by 3 km per hour, she will reach the destination 40 minutes early. If he decreases her speed by 2 km per hour, then she reaches 40 minutes late. Okay, then find the distance and her actual speed and see his timing. So 3 things I need to find: distance, her actual speed, and her time. Okay, so you can see here time is same in both the cases, right? I can see this case here. Time is same in both the cases. That means decreased timing is equal to increased timing. T1 equal to T2. So you can directly write S is equal to twice of S1 S2 upon S1 minus S2. I can write it. Okay. What is S1 S2 here? So 3 into 2. So twice of 3 into 2 upon 3 minus 2. So you'll get S is equal to 12 km per hour. Okay. You get S is equal to 12 km per hour. Right, so her actual speed is got right. What is her actual speed? 12 km per hour. Correct? Now in second case, you need to find time and distance. Okay, so we'll now find time and distance. Okay, so we got this actual speed here as 12 km per hour. We got the actual speed of Ritika as 12 km per hour. Okay, so initially she increased her speed by 3 km per hour, right? So initially the increased speed is how much? So 12 plus 3 15, and later he decreased his later she decreased her speed by how much? 2 km per hour. So 12 minus 2 10. Okay, so I can write that initial speed when speed was increased, right? So what is the increased speed? 12 plus 3, that is 15 km per hour. And what is the decreased speed? 12 minus 2, because speed she decreased by 2 in the second case. So 12 minus 2, 10 km per hour. Okay, so in both the cases in both the cases, ratio of speeds, right? It looks like ratio of speed I can note like, okay, S1 is to S2. So ratio of speed is 3 is to 2. Since distance is constant, so ratio of time will be inverse of the speed, that is 2 is to 3. Okay, that means if time initially she took 2 minutes, then the time she took is now 3 minutes. Okay, what is the ratio of time? At the speed of 15 and at the speed of 10, right? So at the speed of 15, if the time taken is 2 minutes, so if at the speed of 10, time taken is 3 minutes. Okay, what is the difference between these two times? Difference between these two times is 80 minutes. Difference between these two times is 80 minutes, because at the speed of 15 she is reaching 40 minutes early, and at a speed of 10 she is reaching 40 minutes late. What is the difference? 40 plus 40, 80 minutes. Okay, and where does this 15 and 10 comes from? Because you got the actual speed as 12 kilometer per hour. So now in that case, because we got actual speed as 12 kilometer per hour, in that case, what is the increased speed? So Ritika increased her speed by 3 kilometer per hour, so it becomes 15. Okay, it became 15. And in the second case, she decreased her speed by 2 kilometer per hour, so 12 minus 2, it became 10. That's why, right? Difference is 80 minutes, right? That means in the ratio 1 unit represents 80 minutes. Therefore 2 units represents 160 minutes, 2 units represents 160 minutes, and 3 units represents 240 minutes, right? So what is this 3 units? This is T2. What is T2? At the speed of 10. At the speed of 10, right? So I can write, okay, at the speed of 10, understand this, at the speed of 10, at the speed of 10 kilometer per hour, time taken by her is 240 minutes. Time taken is 240 minutes. That is 4 hours. That is 4 hours. Therefore, distance she traveled is speed into time, 10 into 4, that is 40 kilometer. So we got the distance, we got the time, everything we got here. Okay, so time taken here is 160 minutes. In the first case, time taken is 160 minutes. In the second case, time taken is 240 minutes. Okay, so I can also get the actual time. What is the actual time? So actual time will be how much, right? In the first case, she is reaching in 160 minutes. Okay, and she is reaching 40 minutes early. So actual time will be 160 plus 40, that is 200 minutes. So we got all this data here, right? So it's a good question, right? So someone will tell, okay, why to remember these things, right? These things with too much formula. No, see, this is not formula, it's a concept, right? This some formula you have to remember, right? For solving a question faster, because a person who remembers this formula will completely solve this question in lesser time than you, of course, right? So you got to remember these things, okay? And these things you don't find generally in books and all, right? Normal books you don't find and all, okay? So in Arithmetic, I have referred at least 6 to 8 books of different kinds, okay? And I've collected all the concepts from different books. Some are mine also, okay? Some questions are mine also, because I create questions for this mock cats for IMS and Career Launcher, okay? Some questions are mine also. Some questions I've taken from very good books, some concepts, okay? So all those combined, I'm presenting a complete package of arithmetic, okay? This kind of concepts are very less known, okay? So you should able to know it to have an edge over others, right? I hope it is clear, right? So what we did initially, we calculated speed by the simple funda, because T1 was equal to T2. So in the last slide we saw this, we got a speed as 12 km per hour. In the first case, Ritika increased her speed by 3 km per hour. That means her speed became 15, and she reached the destination 40 minutes early. In the second case, she decreased her speed by 2 km per hour. That means her speed became 12 minus 2, 10 km per hour. Okay, and she reached 40 minutes late. So ratio of speeds in two cases is 15 is to 10, that is 3 is to 2. Since distance is constant, so speed is inversely proportional to time. So time ratio is what? 2 is to 3. So in first case, time taken is 2 units. In the second case, time taken is 3 units. Difference of those two times is how much? 80 minutes. Because in first case, 40 minutes early from the actual time. Second case, 40 minutes late from the actual time. So 40 plus 40, 80. Okay, so 80 minutes. So that means for the T1 is 160 and T2 is 240. What is T2? at a speed of 10. Okay. Or I can take it at T1 also, it's your wish, right? Any one speed and time corresponding ratio you can take and multiply it to get distance. Okay. That's the answer. Fine. Let's move to next question. A car travels from P to Q at a constant speed. If its speed was increased by 10 km per hour, it would have taken 1 hour less to reach the destination. It would have taken further 45 minutes less if the speed was further increased by 10 km per hour. Okay, find the distance PQ. Okay, so again same thing here. If speed was increased by 10 time, it would have taken 1 hour less to reach the destination. Okay, so time in first case, again time is what? S plus S1 upon S1 into T1. Okay, by increased speed, right? This is for increased speed. Increased speed. For decreased it is S minus S2. So what is time here? So time in first case, how much? Time in first case is S plus 10 upon 10 into T1. So T1 is 1 hour less, but here it is 1 hour less, and second case it is 45 minutes less. So I should convert this 1 hour into minutes only. Okay, so I'll take 60 minutes. And second case, the same T is equal to how much? Now speed is further increased by 10. It would have taken further 45 minutes less if this speed was further increased by 10. Okay, so speed is further increased by 10. That means in first case it was increased by 10. In second case further increased by 10. So from actual it should be 10 plus 10, 20 increase. Okay, so S plus 20 upon 20. Okay, is equal to what? Sorry, into what? Into T1. So what is it? What is the time? What is the increased timing? So in first case it was, sorry, what is the decreased timing? T1. In first case, it was 60 minutes less than actual. That is T1 is 60 minutes. In second case, it is further 45 minutes less. So total how much less? 60 plus 45. Total 105 minutes less from actual. So into 105. Right. This both are value of T. This both are value of T. Right. So I can equate it. So let's solve it here. S plus 10 upon 10 into 60 is equal to S plus 20 upon 20 into 105. Okay, so we can solve here for S. Like this can go. See, we don't need to convert because rest S and 10, 20 and already kilometer per hour, right? And this 60 is also in minutes, and this 105 is also in minutes, right? So minutes will get cancelled. So no need to convert in hours and all, right? So 15 4 ja and 15 7 ja I can cancel here. 10 2 ja I can cancel here. Okay, so what will be left here? So we are left here with 2 will go here. So it becomes 8s plus 80 is equal to 7s plus 140. Right? Therefore, you get S is equal to 60 kilometers per hour. You get S is equal to 60 kilometers per hour. Right? And now you can put T here. Okay, you can put the value of T here. So T was S. T was this much. So T was this much. You can put the value of S here. So S is how much? S is 60. So 60 plus 10 upon 10, and this 60 minutes now can be written in hours, 1 hour, because all other data is in hour, right? So that means you get 7 hours. 7 hours, right? This is 7 hours, okay? That means 7 hours you get is the actual time. 7 hours is the actual time, and 60 km per hour is the actual speed, right? Therefore, what is the distance? So distance is equal to speed into time. That is 60 into 7. That is, sorry, 60 into 7. 60 km per hour into 7 hours, right? How much it is? It is 420 kilometers. That is the answer for this question. Distance is equal to PQ is equal to 420 kilometer. That's the answer for this question. So this was a very nice concept. So we discussed in this video two very important concepts. Okay. So okay, we'll continue linear tracks in the next video. Thank you.